Okay, for lab today, we'll be using this firing gun that compresses back. So it starts here and then this compresses back and it loads the ball so that it can be fired by clicking this, and it will shoot out. And then we had long alleys where we're going to measure the distance that it travels. So we have a lot of measuring devices, tape, we have protractors, we have so a lot of measuring today. So first I'm going to show a diagram of the setup that we have for this lab. Actually, I'm going to turn it.
And that's why he's having tachycardia, because he's febrile.
So actually, this is a little better. So this is the gun that we've got. So here's where the ball is released. So when we compress it back in the actual spring gun, then we've gone back a distance y. So this is in the spring gun. You can see from this diagram that where the ball releases at this point, here's our positive y direction, here's our positive x direction. So the ball then releases and travels the trajectory down to land, and that's the range that it travels. So this is distance x. And then this is the initial velocity in the x direction that it leaves the gun. There's no y direction velocity, as it's leaving more in the horizontal mode. So this is shooting out horizontally. The velocity, that is the initial velocity leaving the gun, is equal to the velocity that is exiting, that's leaving the gun, that's equal to the velocity, the initial velocity of the projectile is equal to the final velocity of the gun. So as it's leaving the gun, this velocity is what we're going to calculate to be the initial velocity for our projectile motion. So we actually have two setups here. We have one that's velocity that leaves and travels and lands, has a range of x, and in order to have this initial velocity, we actually have this gun that spring loads, and from the spring load to when it releases, we accelerate to get to this initial velocity. So there is an acceleration of the gun. So there is not an x component acceleration once the ball has been fired, but there is an acceleration that occurs in this displacement, in this distance in the gun. So just want to make sure that that's kind of clear. There's two components to this. Because today what we're going to do is we're going to measure this distance y and the distance x. And with those two, we can calculate what this initial velocity is for the ball. Once we have the initial velocity for the ball, we can take how far we had to compress it and can calculate our acceleration that occurred across the compression in the gun then. So we'll calculate the final velocity, which is the initial velocity for projectile motion, and we're also going to calculate the acceleration that occurred in the gun. How many times have you had it?
Did they tell you earlier, see legal or something, that they're supposed to meet with the legal? Yeah.
So now we can measure the range x dimension of how far the ball shot. So we get a Y dimension and an X dimension. Our X dimension is positive. The Y dimension, because it's coming down from where our origin at the projection gun, that dimension is actually a negative because it's going downhill. Average is 14.77.
Against the law.
Area of smoke. Temperature data back up to
Okay, so I'm collecting
So-
data. We took that measurement.
Homework
height.
tonight.
So this is where we're doing the height when it had horizontal travel. So first we got 3 different heights for our measurements. We had 89 centimeters, and that's a negative number because it's measuring down from the origin. That was 89.0.
You ever look to see if you heard back from Dr. Horn?
88.9 centimeters and 89.0 centimeters. So we calculate a mean for that. After shooting the ball, we got a range. The range was 204 meters, 2.06 meters, 2.05 meters, 2.03 meters, and 2.03 meters. So that's how we collected the range, the distance traveled X. Okay, with this data, now you can calculate what the initial velocity was as it was leaving for the horizontal motion. So leaving the compression gun and traveling horizontally. So you can use that in that equation for initial velocity using
Demery?
X and Y.
Oh,
Was,
okay, I didn't know that.
on your pre-lab.
I don't know. They haven't.
Okay, the second data that we collected
Recorded like her, Annika.
was at an angle. So here's the different degrees. From 0 to 50 degrees. Again, we measured our height Y. And we took 3 measurements of the range so we can get a mean for that. The data that we captured for the first one was 0.89 meters. And this height again is going down, so this would be a negative. It would be negative 0.912 meters. And negative 0.928 meters.
She's the one.
And negative
She's the one that kicked Brayton off of the top 5, isn't she?
meters.
Oh, okay. Who kicked him off?
And negative 0.976 meters. And last, negative 0.983 meters. So there's all the heights for the different angles. Now, the range, how far did the ball actually travel out? What was its X direction? Okay, we did this from the first one, 2.04 meters, 2.06, and 2.03.
He's just the advisor is
And
all.
you find the mean for that.
I'm not a
The
huge
second,
Brett English
at 10
fan.
degrees, was 2.47 meters, 2.45, and 2.46
That was the first batch.
Serious?
for 20
Disgusting.
degrees, 2.86 meters,
You know what I'm saying?
2.87,
What's that?
2.84 meters. For 30 degrees, it was 3.07 meters,
Jeez, Kelly.
3.09,
Kelly been like asking me
meters.
something, and I've been trying to find out what I
and
want to do. I know that I
3.05
want to go into
meters.
healthcare, but I don't know.
All right, for 40 degrees, the range was
I thought that you would know about.
3.13 meters, 3.12 meters, and 3.13 meters. And last, 50 degrees was 2.90 meters, 2.91 meters, and 2.90 meters. So with the range data, you can get the mean. On the group lab, you don't have to do any calculations with this data. This is all data that will be used for your individual lab.
We don't have chocolate milk, right?
No.
What you will then do is with the data that came back from your initial velocity, when we then are going to analyze the gun, we look at what was the mass of the ball, and we have the reading for that from the video clip of massing the ball, and then measuring how far we pressed the plunger back, this dimension, was 4.2 centimeters or 0.042 meters. This is what we can now
You
use
said you don't have
to
any
find the
homework?
acceleration that happened in the actual compression gun. And then this is to diagram and to show the sketch where you have your reference axis, the positive y, positive x,
please
and where
check.
the origin